12.5, circles in the coordinate plane. This is kind of a short one, kind of an easy one, a nice way to end chapter 12 here. We are going to write the equation of a circle and find the center and radius of a circle. So we start off with our theorem here. Our theorem is the equation of a circle, and we are told that the equation of a circle with center at point HK and radius R is this formula right here. X minus h quantity squared plus y minus k quantity squared equals r squared. And if we look over here at our diagram, we see that HK is the center and the radius has a length r, and it touches our circle. It ends on our circle at some point xy. Remember, the radius goes all the way around, so we can use any point xy that is on this circle in this equation. All right. All theorems have a proof, the proof of why it works. And you should have guessed it by now. We are in the coordinate plane. What do we use in the coordinate plane? The distance formula. And we are interested in how long is our radius. Radius goes from the center to a point on the circle. And you remember our distance formula is the square root of the quantity x2 minus x1 quantity squared plus the quantity y2 minus y1 quantity squared. That's our distance formula. And you notice that our 2 points here, we can name them x1, y1 and x2, y2. And if we put them into our distance formula, the length we're looking for is the radius. And we simply substitute in. If we square both sides to get rid of our square root, we end up with, we're going to square both sides. Remember, the square of a square root is whatever is inside of it. We square this side too, and we end up with the equation of a circle. You can call this the standard form of an equation of a circle, or just the standard equation of a circle. So how do we apply this? We want to write the equation of a circle. And what is the standard form, standard equation of a circle? If we are given a center and a radius, we are going to label our center. We know that that happens at points HK, and our radius is 7. So we simply substitute in, we write our formula for the equation of a circle. We substitute in for h, we substitute in for k. Now, something to notice here, this is one of those equations that starts out negative. This is x minus whatever value of h and y minus whatever value of k we are given. So here our h is positive, so it's just x minus 5, and our k value is negative, so it's y minus, and then we substitute -2. So be careful of your negatives there. We've encountered these negative equations before, and just anytime you see a negative, it's a good idea to be careful. You stop and think and go, ooh, negative. Watch out for those. Okay, so we know minus a minus is plus plus, so we get a +2 there. And don't forget to square your r squared. Put a little note over there to ourselves. Make sure that you square the r. So those are the two places you will make mistakes. And we simply just end up with the equation of our circle. We know that its center is at 5, -2, and its radius is 7. All right. Let's use the center and a point on the circle. This one gives us a center So we know that this is h and k. Oh, I see a negative there. I know I need to be careful. And it's going to pass through some given point. We know that it's a point on the circle. You can use any point on the circle and you will get the same answer. We want to find our radius, so we are going to label this point xy. We know that we have, we're going to call this, this is x2, y2, x1, y1. Labeling doesn't matter which one you label. Just remember to label them. So we know we use the distance formula, and the distance we're looking for is our radius. So we write our distance formula. We simply substitute in for x2 minus x1 plus y2 minus y1. We do the math. Remember order of operations. You do the parentheses first, then you square it, then you add them together. And our radius has a length of square root of 26. We're going to leave it like that because it's an irrational number. And then we go back and we know our radius is the square root of 26 and our center is at 1, negative 3. Now don't forget this is h and k. So we write the formula for our equation of a circle. We substitute in, being careful of this negative 3 here. We have a minus and minus, and we do the math. Remember that the square of a square root, because it is r squared, don't forget to square your r, is simply the number inside. The square of the square root of 26 is just 26, and we get the equation of our circle. We know that its center is at 1, negative 3, that's why it's positive there, and has a radius of the square root of 26. So that's easy enough. All right, pause the video and try the examples. All right, these weren't too bad. We were asked to write the standard equation of a circle. We were given a center of 3, 5 and a radius of 6. So I labeled h and k as my center, and my radius is 6. I wrote my formula for the equation of a circle. I substituted in and did the math. There were no negatives this time, so everything came out nice and neat. In the second one, our center is at negative 2, negative 1, so I'm already thinking have to be careful of those. And our radius is the square root of 2, and we might go, oh no, square roots. But don't worry, because don't forget, we're squaring r. So I write my formula. Always a good choice. Label everything, write your formulas, and substitute in. I substitute in, and remember that this equation is x minus, and my value of h is negative 2. So I have to write everything. Don't forget that minus. So, and then y minus negative 1, and I have the square root of 2, and r is squared, so I'm squaring that. So now I do my math. Minus minus is plus. So x plus 2, quantity squared, plus y plus 1, quantity squared, and the square root of 2 squared is just the number inside. They're opposite operations and undo each other. So that is just 2. Those were pretty easy. The next problem said, write the standard equation of your circle given your center that passes through a given point. So we know we're going to need to use the distance formula. So I am writing out my important information here. My center, HK, is at 4, 3, and I go through a point, negative 1, 1. I label those x1, y1, x2, y2. Doesn't matter the order. I'm using my distance formula. My distance is the radius, is what I'm trying to find. I substitute in, being very careful with my negatives. And do the math in the parentheses, order of operations here. So I get minus 5 squared plus a negative 2 squared. Don't forget, when you square, negative 5 times negative 5 is positive. Be careful with those negatives. Negative 2 times negative 2 is positive. So 25 plus 4 is 29. R is the square root of 29. Then I am supposed to write the equation. So I write my formula for the equation of a circle. I substitute in, and yay, the square root of 29 squared just becomes 29. This is the equation of a circle with the center at 4, 3 and a radius of square root 29. So not too bad. Label everything, write your formulas, and be careful with those negatives when you're substituting. All right, let's look at our next example. We want to graph a circle given its equation. So when you make a call on your cell phone, the cell phone tower receives and transmits the call. You can monitor the range of a cell phone tower using a circle. The tower transmits equally in all directions, which is pretty much the definition of a circle, equidistance from the center. So we know that we have our given equation here, represents the position and the transmission range of the cell tower, and we want the graph that shows this. So we are going to use this. We know that our formula is x minus h and y minus k and r squared. So I know that h is going to be 7, but my formula is y minus k, and I have y plus 2. How do we turn a plus into a negative? We use minus minus, right? Minus minus becomes plus, so plus becomes minus minus. So k is going to be negative 2. So I know that hk is 7, negative 2 is my center, and r, don't forget that r is squared. We have r squared equals 64, so we want to square root both sides, which is going to give us r equals 8 units. If we wanted to graph that, we would then graph our circle with a center here at 7, negative 2, and then we could use our compass to measure out a radius that measures 8 units, and then we would just draw a circle around it. Or we could just go from our center here, if we don't have a compass, and we can just count out 8 units in this direction, 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 and neatly and carefully freehand a circle around. Alright, pause the video and do the last example here. Okay, part A asks us, in the previous problem, what does the center of the circle represent and what does the radius represent? Well, if you remember, we were talking about a cell phone tower, so the tower sits at the center, and the radius of the circle represents the transmission range. Graphs tell stories. And part B, we are asked to find the center and the radius of the circle with this given equation. So I know my equation of the circle. I know that it's x minus h quantity squared and y minus k quantity squared. So I could find the center. Both of these are minus, so we're in good shape. H is 2 and k is 3. And I know that my equation also says radius squared. So my radius squared is 100. I square root both sides, and my radius is 10. I have a center of 2, 3, and a radius of 10. And then we are told to graph this circle. So we come over to our coordinate plane, and we put our center here at 2, 3. And I don't have a nice neat compass, so I am going to count 10 in this direction. It goes a little bit off of my graph. 10 in this direction, 10 in this direction, and 10 in this direction. Okay, and if I had a compass, I would just put my pointy part on the center and my pencil on the outside and draw a nice neat circle around here. But since I don't have that, I'm just going to neatly freehand in the best circle that I can. And if you go quadrant by quadrant and think about making it a little bit curvy, that's not too bad of a circle. And we can label this radius 10. So circles in the coordinate plane are probably easier than any other shape we have done. And make sure that you are labeling everything. Label your center, HK, any other point, XY. If your radius is R, if you're doing distance formula, make sure you are labeling X1, Y1, and X2, Y2. Be careful of those negatives. The formula starts out negative, so if you're putting in a negative number, it's going to become positive. Make sure you are always writing your formula as negative, X minus and Y minus, and then you put in whatever number. Also, don't forget to square R, or if you are trying to find the radius, to square root to get R. I think you will do wonderful with circles. And we are finished with chapter 12.